Okay, so far we've talked about the atom basically being made up of, we've talked about protons, we know about neutrons, we know about electrons. So what we're going to talk about today is, now we know that protons and neutrons can be broken down into something called a quark. Okay. Now, so if we think about, like if we had one proton, okay, so say this is our proton, that it's composed of up quarks and down quarks. So, I'll just get my notes here. So the proton is composed of two up quarks, so 1, 2, and one down quark. So I'll just represent them right now with an arrow. And then the neutron is composed of one up quark and two down quarks. Okay, so the quark theoretically cannot be broken down any further than this, okay? So we broke, before we thought we couldn't break down the proton or the neutron, but then they discovered quarks, okay? So this is a diagram of what we call the Standard Model. Okay, so this is the representation of our current understanding of the atom. So it's like we went from, you know, Bohr, Rutherford, looking at all these things, and now this is what best describes the atom. So just skip ahead, and then we'll come back to this page. But so the Standard Model refers to the current theory that is used to describe the nature of matter in an atom in terms of wave, particle, duality, and the fundamental forces. So before we said, okay, well, you know, Rutherford's model can't be final because if we had those electrons going around in orbits, then they would collapse on themselves because it would release EMR and spiral in. And so more data, more investigation led to the Standard Model, so describing it in its entirety. So go back to the first page now. Oopsies. Okay, so take out a highlighter or something if you have a highlighter, or just different colors. So what we've talked about so far is we know about electrons. We know about electron neutrinos. Okay, so our beta negative and our beta, or our electron neutrinos, so our ones that are antineutrino and neutrino. And in one of your workbook questions, it talked about a muon. Remember that? There was a question that had muons in it. We don't have to know too much about those. We have talked about, we know about photons. Okay, we've talked about photons, and that's about all we've seen before. Okay. So the electrons and the muon and the tau are all, and tau neutrino, muon neutrino, electron neutrino, these are all part of a group called the leptons. And then here is another group called the quarks. Okay? Now the quarks, we are just going to focus on the up quark and the down quark. So I'm circling just the things that you need to know for this course. Okay? But I still wanted to show you the big picture of it so that you could see where it all fits in to the current model. So this is these are describing kind of the particles, okay? Now the red on my sheet here, these are called the force carriers. So it's what is carrying a fundamental force. So the photon, this is carrying, basically, this is our strong EMR. Okay. Now, the Z and the W's are called bosons, okay? These bosons carry weak electromagnetic interaction. Okay? And we'll see in our lesson that we need to know a little bit about the W boson. Okay, so I'm going to show you where that fits in. So you need to know about the W boson, so I circled that one too. And then the gluon, okay, it's kind of like it sounds, it's gluey, so it sticks stuff together. So this is a strong, it's responsible for strong nuclear force, binding quarks together. So it's gluing the quarks together. Now, there is this other particle here that's been predicted called the Higgs boson. Okay? So it's kind of exciting because it has now been discovered. As I said a couple weeks ago, when they turned on the Hadron Collider, they discovered it. So it's like, okay, well, we can take that out now, right? It's crazy. Changed history just a couple weeks ago. Physics textbooks have to change now, right? It's cool. Stuff is always changing in science because we should always be exploring and asking new questions, right? So, so this is kind of, this is really cool, you know. And when I keep showing you that one Symphony of Science video, you know the one I'm talking about? I'm making you a Jeopardy. The quantum mechanics Symphony of Science video I've showed you several times.